Homework 14, section 7.2, applications of the standard normal distribution, video 3. We're going to use the z-table again in another non-standard normal distribution, and as you probably have seen by now, we're using the same context. The mean term for pregnancies is mu equals 272 days, with a standard deviation of sigma equals 9 days. But we're going to answer a different question this time. Is it unusual for a pregnancy to last at least 290 days? Well, first off, recall that an event is considered unusual if the probability is less than 5%. That's considered industry standard, if you will. So we're really seeing if this probability is less than 5%. But what's this probability that we're looking for? Well, the probability that X is greater than or equal to 290 days, because that's what it would mean for the term of the pregnancy to be at least 290 days. Let's figure out the corresponding Z problem that this would be correlated with. But first, let's sketch a picture of what we're looking for. In the distribution that we're given with a mean of 272, so we put 272 in the middle of the bell curve, we're looking for the probability that X is greater than 290. 290 would be to the right of 272, and since we're talking about the probability of being greater than 290, we're looking for the area to the right of 290. But what would this look like in the Z picture? Well, we know the center is 0 in a standard normal distribution by definition, but we've got to calculate the z-score that we're looking to the right of. So to calculate the z-score, take the x value that we're converting to a z, 290, subtract the mean, which is 272, and we're going to divide that by the standard deviation, which was 9. This actually comes out pretty convenient because the difference is 18, and 18 divided by 9 is exactly 2. So to answer the question that was asked, we need to answer the equivalent question, what's the probability that z is greater than or equal to 2? We could actually empirical rule our way out of this, but let's not always rely on that because most of the time we can't. Use the z-table. So in the z-table, we need to think of 2 as a 2-digit decimal, so we'll call it 2.00. The numbers on the left and the right side of the decimal place are what would be in the left column of the table. So we would go down to the 2.0 row. And then the second decimal digit place, that sounded funny. The second decimal place would be the column under which we look. And since the second decimal place is 0, we would look under the very first column. So if we look across the 2.0 row, I meant for these to be ellipses, not an arrow. If we look across the 2.0 row down the 0.00 column, see if I can figure out what we should get. We should get 0.9750. It's not what we got. We got 0.9772. Oh, okay. We got 0.9772. I was close. Now be careful. That's not the answer to this question. Why is the answer to this question not 0.9772? That's the number that's in the z-table when I look up 2.00. It's because the z-table tells you left areas. Left areas. We're looking for a right area. And do you remember how to find a right area when you know a left area? And the answer is the right area is equal to 1 minus the left area, because the total area is 1. So the answer we're looking for is not 0.9722, It's 1 minus 0.9772. I think I just read that number incorrectly a minute ago. But regardless, we need to calculate 1 minus 0.9772, which is 0.0228. And that would be the answer to our question. Or as a percent, 2.28%. But let's get back to the question. Is it unusual for a pregnancy to last at least 290 days? Well, assuming everything went according to plan, and I'm pretty sure it did, I don't see any mistakes, the probability of a pregnancy being greater than or equal to 290 days is 2.28%. That is less than 5%. So the answer to this question is yes, it is unusual for a pregnancy to last that long.